Here's a quick video on a circuit I came across recently in a homework problem. So you're given a step input of 12 volts to this circuit and you want to find the voltage across the capacitor here. And you know from circuit theory the voltage across the capacitor is this equation here. So one time constant, we're going to have 0.63 V out. At 4 it'll be 98% of V out, and at 5 it's basically V out. But the thing here, it's tricky, is you don't know how to get the time constant from this because you have two parallel resistors. And two ways to do it. The first way is you could treat this whole bottom part as an impedance, treat the top part as an impedance, voltage division, and you get a transfer function. But I'm going to use Thevenin's theorem because I think it's a little bit faster. So Thevenin's theorem says we're going to take the circuit and we're going to isolate what we want, which is voltage across the capacitor here. So let's draw that. And we want to find the impedance looking in from those two terminals. And Thevenin's theorem also says we can remove all voltage sources and treat them as short circuits. So that leaves us with that. And if you redraw that, it's basically just this. And it's obvious that the impedance looking in is just the parallel combination of these two guys here. So if we actually take the parallel of those two resistors, we get 4K in parallel with 6K, 4 times 6 over 4 plus 6. That's 2.4 kilo ohms. So then our equivalent circuit here, add this back in, 2.4K, 1 microfarad, T equals RC, 2.4 milliseconds. And so yeah, then we're going to be 63% of the way at 2.4 milliseconds. It's going to be fully V out at 5 time constants, which is 12 milliseconds. All right.